So today we're going to solve logarithmic equations. So now we're going to add some equal signs in them. A couple examples of problems are over there on the right, but we'll work through them in just a minute. So here we have two equations. There's only one log involved in both of them. So anytime you have one log involved, you're going to automatically write your equation in exponential form. So practice what we did yesterday. So looking at this problem here on the left, 4 is my base, this is y, and this is x. So it's log base b of y equals x. We want to rewrite it in exponential form. Exponential form is b to the x power equals y, or y equals b to the x. Either way you write it. So if I move the numbers around, I'm going to have b to the x power. Well, b is 4, x is 2. So I'm going to have 4 to the second power equals y. In this case, we said y was what's in the parentheses, 2x. We do know that 4 squared is 16, so now we have 16 equals 2x. Beside it, divide both sides by 2 to get an answer of x equals 8. The second one sometimes stumps students because there's no base written. Anytime there's not a base written, it's base 10. That's your b value. This is y, and this is x. So we're going to write b to the x power equals y, in this case, 10 squared equals 5x. Well, 10 squared is 10 times 10, which is 100, equals 5x. Divide both sides by 5, and x equals 20. Questions on these two? So these are really as simple as it gets. This one's not too terribly hard either. So log base 9 of 4x plus 1 equals 2. Rewrite in exponential form. So not 9 squared equals 4x plus 1. Well, 9 squared is 81. So 81 equals 4x plus 1. Think back to Algebra 1. We learned how to solve equations there. Subtract 1 from both sides to get 80 equals 4x. Beside it, divide it, so x equals 20. That one just had an extra step in it. When we get to the next slide, we're going to have more than one log. So here we have 2 logs on the left side equals 1 on the right side. Anytime you have logs on the same side of each other, first thing you're going to do is use our properties of logs that we learned yesterday to combine these. So if I combine these 2 logs, they're being added together, which means I want to use the product property to combine them. In this case, 8 times x, I'm just going to write 8x. Keep in mind we were not given a base. Anytime you're not given a base, you're using base 10. The common log is base 10. So now that we've condensed these, we can go ahead and rewrite this in exponential form. That would be 10 to the first power equals 8x. 10 to the first power is just 10. So 10 equals 8x. We're going to divide both sides by 8 to get x equals 10/8, which reduces to 5/4. Or if you convert it to a decimal, 1.25. So 5/4 or 1.25 would suffice. Making things a little bit trickier over here on the right side, we again have two logs on the left side of the equation. We want to combine them. Again, we have addition, excuse me, here in the middle, so we're going to use the product property again. When we use our product property, I have to take and multiply this times this. Since we have two terms in that second set of parentheses, that 2 from the first log must get multiplied by both. So I'm going to take 2 times x to get 2x, and 2 times -5 to get -10 when I combine those. So a lot of times I'll have students who just multiply the 2 times the x, and then they bring down that -5. You've got to multiply the -5 times the 2 when you combine them. So now we have log base 7 of 2x minus 10 equals 2. We can go ahead and write that in exponential form. That would be 7 to the second power equals 2x minus 10. 7 squared is 49. So now we have 49 equals 2x minus 10. We're going to add 10 to both sides. So 59 equals 2x. Divide both sides by 2 to get 59 over 2. Or again, if you convert it to a decimal, 29.5. So finally, answer 59 over 2 or 29.5 as a decimal. Questions on these two? For this question, we have, again, 2 logs on the left side. We want to start off by combining them. So when we go to combine these two, we have subtraction between the logs, which tells me I'm going to use the quotient property. So log base 2 of 8 divided by, 3x minus 2 still equals -4. So we've condensed down into one logarithm. After we do that, we now want to rewrite in exponential form. So 2 to the -4th power equals 8 divided by 3x minus 2. Remember how we talked a couple of days ago about negative exponents creating fractions? The easiest way to solve this problem is to change this, that's really to change this right here into that fraction that we had discussed. So if I change this into the fraction, we have 1 divided by, since I've made it a fraction, I'm going to take 2 to the 4th power, which is 16. If you don't believe me, type 2 to the -4th power in your calculator, and then type 1 divided by 16, and they will give you the same answers. We're going to leave the right side alone for the time being. Now we have a proportion. To solve proportions, we've reviewed these in this class. We're going to cross multiply. So I'm going to take 16 times 8. I'm actually going to go up here so I have more room to get 128. Then I'm going to multiply my other diagonal. I'm going to take 1 times 3x minus 2. Well, 1 times 3x is 3x. And 1 times minus 2 is still minus 2. So now I have 128 equals 3x minus 2. Going to go ahead and add 2 to both sides to give me 130 equals 3x. We're going to divide both sides by 3. That gives me x equals 130 over 3, or if you want the decimal, 43.3 repeating. Questions on this one? Moving on to my favorite one. So here we have logs given to us on both sides. Keep in mind there's nothing being added or subtracted out at the ends of either one of them. When this happens, if log of 7x equals log of 5x plus 10, we are allowed, since we have one log on the left and one log on the right, we're allowed to cancel the logs out, including the bases. So here the bases of 10, they're not written. We would still cancel them both out if they're both log base 6. When we cancel them out, that just leaves us with what's in parentheses. 7x equals 5x plus 10. Once you have this, you're just going to think back to algebra 1 and solve for x. So subtract 5x from both sides. So 2x equals 10. We're going to divide both sides by 2 to get our answer of x equals 5. So no condensing necessary because we had one log on the left side, one log on the right side. For the question on the right, the same thing is true. Here we have one log on the left equals one log on the right. The bases match, so we can cancel those logs out, leaving us with 4x minus 1 equals 2x plus 3. Once you cancel them out, we're just going to take the equation we have now and solve for x. So subtract 2x from both sides. Add 1 to both sides. And then we're going to divide by 2 to get our answer of x equals 2. So pretty easy to see why those are my favorite. We don't really have to do anything with the logs after we cancel them out. Last two. So looking at question number 1, we have 2 logs on the left equals 1 log on the right. The first thing we want to do, we want to first off condense the 2 logs that are on the left side. So if we're going to condense them, we have addition, which means we're going to condense using the product property. Product property says we're going to take x and we're going to multiply it by 7. 7 times x is 7x. So now we have log of 7x equals log of 37, and we've turned this problem into one like on the last slide. We have 1 log equals 1 log, so we're just setting our parentheses equal to each other. In this case, 7x equals 37. Divide both sides by 7, and x equals 37 over 7. Or again, if you convert to a decimal, 5.28. So just one extra step from the ones on the previous slide. For question number 2, on the right side, again, we have 2 logs, one on each side of our equation. The bases match, so we're canceling out the log and the base with the log and the base on the opposite side. However, when I do that, it leaves me with 16 plus 2b equals b squared minus 4b. First thing I notice about that, I have something squared. Anytime we have something squared, we're more than likely going to have to factor it. In this case, we're going to move everything to the right side and use our asterisks. So I'm going to subtract 16 and subtract 2b from both sides. That gives me b squared minus 6b minus 16. Using b squared minus 6b minus 16, I'm going to put that into my asterisks. I have 1 in the top left and top right, negative 6 in the bottom middle, and 1 times negative 16, or negative 16 in the top middle. So I'm looking for 2 numbers that multiply to give me negative 16, but add to give me negative 6. Those 2 numbers will be negative 8 and positive 2. So they multiply to give me negative 16 and add to give me negative 6. I now have factors of b minus 8 and b plus 2. We know we have these 2 factors being multiplied together and their product is 0. So we're going to use the 0 product property to set these both equal to 0. That gives us 2 answers of b equals 8 and b equals negative 2. Technically, we should have to check these in the parentheses. Remember, whatever you have in your parentheses can't be negative. So if I take this first set of parentheses and I plug 8 in here, I'm going to have 16 plus 2 times 8. Well, 16 plus 16 is definitely positive. When I check 8 in the second set of parentheses here, I have 8 squared minus 4 times 8. Again, gives me a positive, so it's okay. So I know 8 checks out. And then we're going to go check negative 2. So same process for negative 2. I'm going to plug negative 2 in for b in my parentheses to make sure I don't get a negative. So 16 plus 2 times negative 2, that's 16 minus 4, which is 12. So the first set of parentheses is okay. Then I'm going to check it in the second set of parentheses. So here, b squared, I'm going to take negative 2 squared, which gives me 4. -4 times -2 is +8. 4 plus 8 is 12, so it also works as well. So sometimes I've had students think, hey, one of them works, the other one must not. That's not the case. In this case, they both actually work. Neither one is extraneous.